The Emergency Need Transmission System is a wildland safety sensor network which provides accurate, up-to-date locations for first responders, which allows for a narrowed search area for at-risk or lost hikers. The ENTS network consists of two pieces, a strong loop API and a trail sensor network. The strong loop API has two models, a location and a user, and the trail sensor network has a head and a node. First, let's talk a little more about the location model. It supports all basic REST functionality, as well as further customization through methods. For now, let's look at how to create a trail within the ENTS. After selecting Post, we are presented with a generalized form of the model to know how to format our data. We can click the model schema to copy it and enter our desired GPS coordinates and name for the trail. The nodes section is where we will put the GPS coordinates of the nodes within the network to be related to the head. We can also name the network and give it a system ID. After posting, we can see that it has returned a success and verified the information we have given it and is completely ready for use. Next, let us examine the user's model. It too supports all RESTful API operations and method customization. But for now, let's look at how to find all the users which are currently recorded within the system. After selecting a generalized GET, we are presented with a desired model for the data we will be sending to the system. This consists of a system-generated ID, a user token which is generated by the head node, the devices associated with that user, the trail it is on and the location it was last seen at, as well as the last time it was updated. After sending our GET request to the server, it returns all users within the Mongo database back to us. This contains the previous data fields, which makes this a great way to get an idea of how many people are on a trail at any given time. Now, let's take a peek at the hardware. The head node of the ENTS is controlled by a Raspberry Pi 2.0, which has a Bluetooth module to detect users, a Zigbee wireless protocol mesh module, and an internet connection in order to post user data back to the server. It also features a touchscreen in order to allow users to register, unregister, or for first responders to see who is in need on the trail. The user interface has three options as mentioned before, the first of which allows the user to register with the system. After pressing the first option, the head node prompts the user to wait for their device to be detected and will let them continue once it has been. It will then display their randomly generated nature name, which they can send back to friends or family in order to observe them on the trail. The second option is for users who are choosing to leave the trail, and again prompts them to wait for a Bluetooth scan before allowing them to continue. Once finished, it will notify users that they have been purged from the database and allow them to continue on their way. Now let's check out the node hardware. The satellite node is controlled by an Arduino Uno and consists of a Bluetooth 4.0 LE listener module, a Zigbee wireless protocol mesh module, and an external power source. These nodes are placed along the trail, ideally using steel poles, but here human-powered, and feed back Bluetooth device data to the head node to be posted to the server. Now, let's look at what it's like to use the system. The friend or family of a hiker can enter their randomized username into our website's search map. After pressing the Find User button, they're presented with the head of the trail they are on, as well as their last seen location, represented by a small hiker spread on the trail. The map can be zoomed further in order to get a better idea of how far they are from the head of the trail. To conclude, we've talked about what ENTS is, a wildland safety aid which will allow for quicker searches for and more rescues of lost or at-risk hikers. We've also spoken of how it does this, a Zigbee mesh network which sends user Bluetooth data back through our API, which keeps up-to-date info on user locations for their safety. Thank you to our advisors for their support. And thank you for watching. Travel safe.